Nodes abstraction is built on top of graphs abstraction. In this level of abstraction, the MetaGraph construct allows you to create graphs of graph modules from the previous level of abstraction. That's why we call it MetaGraph. Not all the modules in this level of abstraction are built based on the MetaGraph construct. In other words, not all of them could be represented as graphs of graph modules from the previous level of abstraction. The modules that are not based on the MetaGraph construct perform housekeeping tasks. For example, some of these nodes focus on the interaction of the users with the platform. These nodes include the logger node and the interactive input node. The dataset and dataset sync nodes are also not based on the MetaGraph construct. They are data connectors and allow the interaction of the platform with the different data sources. The chatbot node is not based on the MetaGraph construct as well and creates chatbots either using the external API calls such as OpenAI or based on internal LLMs. The modules that are based on the MetaGraph construct are classifications, LLMs, MetaGraph eval, and MetaGraph loss. The loss and eval nodes are not based on the MetaGraph construct and therefore they don't have underlying graph representation. However, they are wrappers for MetaGraph loss and MetaGraph eval nodes. In order to demonstrate the construction of the metagraphs using the MetaGraph construct, here we are going to build a classification network for MNIST dataset. This metagraph will have two nodes, the feature extractor node and the classification node. The feature extractor node takes images as inputs and outputs feature maps. The classification node takes the feature maps from the feature extractor node and outputs the class prediction. We save this metagraph as MNIST CLS.net. After switching to the graph interface for the feature extractor node, we are going to use the ResNet34 smaller graph that we created before. Currently, we don't have a classification node in our graph personal library, so our plan is to create a classification node next. A classification node in the MetaGraph MNIST CLS.net is the graph construct. Therefore, we switch to the graphs abstraction level. First, we save our classification head as MNIST CLS head. Our classification graph will have a single stage node. We rename this stage node to CLS head stage. This stage node, being the only node for this graph, receives the feature maps and outputs the class prediction. Therefore, it has to be both the input and output nodes for this graph. Next, we need to configure the internal structure of this stage node that performs the class prediction. In other words, we need to add the configuration that takes the input feature maps and outputs the class prediction. One approach to do so is to use the block config and add the layers that perform the class prediction directly to the layers parameter of the block config. Another approach that we are going to use here would be first to add the block that does the class prediction to our personal block library and then use it as the block of this stage node. That is what we do. We switch to the block's abstraction level. We save it as MNIST CLS block. Next, we add the layers that perform the class prediction. The first layer in our block is the global average pooling layer that converts each channel of the input feature maps to a scalar value. We expect the feature vectors generated by this global average pooling layer to have dimensions of 512 since the feature maps generated by the feature extractor node have 512 channels. The second layer that we add is a linear layer with the input size of 512 and the output size of 10 since the MNIST dataset has 10 classes. The last layer of the block is the softmax layer. Now that we have added this classification block to our block personal library, we go back to the graph's abstraction level and use this block in the stage node of the classification graph. We choose MNIST CLS block as the block for the single stage node of our classification graph. Perfect. We are done with the construction of the classification graph. Now we can switch to the nodes abstraction level in order to finish the construction of the MNIST MetaGraph classification network. We add the classification graph that we just created to our MetaGraph. We make the feature maps generated by the feature extractor node to be passed to the classification node. We inspect the internal layers of the classification node to be the global average pooling layer, the linear layer, and the softmax layer as we said before. We set the feature extractor node to be the input node of our graph and the classification node to be the output node of our graph.